Hello and welcome to this video on amortization tables. You're going to go, what on earth is an amortization table? Hold your horses. I'm about to show you. My name's Darren from Maffs Guru. Thank you very much for coming along and joining and hopefully watching this video and smashing amortization tables, which actually covers 2 videos, believe it or not. It just shows how important they have become in VCAA's eyes, and obviously understanding how to read them and do them and all those type of things is great. Before I get into this, do me a favour, head over to YouTube and subscribe to my YouTube channel if you can. Yes, it's under Maffs Guru. Turn off notifications if you think I'm going to spam you. I promise I'm not. I tend to release 1 video a day, a few times a week. If possible, just to keep on top of all the content that is out there. But by subscribing, you just actually let me know that someone out there is watching the video other than my mother. I'm on other social media as well, all under the handle Maffs Guru. Would be good to see you there. Now, generally speaking, this is the stuff I'm going to cover in the lesson. Pause the video if you wish to and have a read over it. It'll just give you an indication of what we're going to cover. But the lessons are mapped against the Cambridge textbooks. Thank you, Cambridge, so much for allowing me to use your textbooks and your examples. You guys literally rock. I couldn't be more grateful. Seriously, I love your questions. Now, this is the second lesson in what is effectively chapter 8 until they change the textbooks and none of this will work out anymore. But this is the second lesson that's building closer and closer to using the financial solver of your calculator. If I have to see this formula much more, I'm going to be in therapy. I promise I'm going to be in therapy. Anyway, you're probably wondering, am I slightly unhinged? Let's not be personal, it's a little hurtful. But the idea is now we're starting to use different language. We're looking at the idea of a principal, money we pay in, money we take out. We know that R is my multiplier. It might be an interest rate, and it's going to be a value that probably starts with 1 point because interest in maths is always added on. VN, my previous term, this here is going to be some payment into or some payment out of my account where my R value here, depending on the context of the question, will be 1 plus R over 100, etc., etc., etc. Now, because Barry is a pain in the proverbial, he's decided let's not call it a bank statement because very few people nowadays seemingly read bank statements or probably even get bank statements. Let's call this an amortization table. Now, probably any accountants who are listening to this are turning around going, he's wrong. Okay, it works for me. But the point of it is, let's just pretend an amortization table is effectively some sort of bank account where we have I don't know, some indication of what's going on, not always given, money paid in, money paid out, how much we've got. And somewhere in this paid in, there is interest. Somewhere if you look at a bank account, they'll tell you how much interest you get. For me, it's about 3 cents a month because I am fairly broke. But let's just think of amortization as bank accounts. And here is an example of an amortization table. The language used is really, to be quite honest, annoying. All right? But basically, if we can understand the language, we can sort of work out where the values have come from. And these notes are all downloadable. So anything you see behind me, including all my scribblings over it, you can download and put into your summary book, do what you need to do with. Many times I say, before I start talking, it's an idea to print them off because you can write all over them with stuff that I don't write down or that might be important to you. But here we go. Payment number, that seems fairly obvious, yeah? If I have a super, I'm going to pay money into it. If I have a loan, I'm going to pay money into it, to reduce my loan. So payment number makes sense, 0. Now, we always start with payment 0 because that effectively stands for my opening balance, right? So again, as I say here, the principal amount of my loan, $1,000. That becomes a massively important figure. Right, payment. What does it mean by payment? Well, if I've got a loan, I'm going to make payments. In this situation here, I'm making the same payment every single, let's say, month, for example, or weekly or whatever. I'm paying $250. Interest. Every single account will charge you interest. Now, in this situation, the interest seems to be decreasing because obviously I'm paying off my loan. The less I have in my loan, the less interest I have to pay, right? That's a whole concept of banks. Principal reduction. This is the one that tends to confuse people because the principal is basically the previous balance. And a lot of people think, oh, well, this is the principal of my loan. The principal sort of changes. At the start, my principal was $1,000. But then after 1 month, my principal changes to $762.50. And then my principal changes to $522.03. And so it goes on. So my principal reduction says, after I've made a payment of $250 and been charged $12.50, my balance is actually reducing by $237.50. Now think about that. I've paid in $250. The bank, however, are charging me interest at $12.50. So my balance is actually only reduced by $237.50. That value minus that value gave me that value. And if I do my balance, that $1,000 minus my principal reduction, it will give me this $762.50. Now I'll talk over more examples here, but that's the basis of all of the questions that you will be doing. And that one thing you'll need to do is work out your interest rate. And again, that's relatively simple once you know. But in this situation, a principal reduction, as I say here, for a loan, you take the payment, you subtract the interest, and that is your principal reduction, okay? Now I can miss out values of this table and use the other information to help me back fill in, which again is where VCAA try and trick you. Now, we have seen this formula sort of before. I slightly rewritten it in this example, just so that it's a little bit simpler for you guys to apply to the knowledge here, all right? If that made any sense. Interest per compounding period. So I've changed it now. Previously I called it the interest rate, now I'm calling it the interest per compounding period. Is equal to the amount of interest charged divided by the balance from my previous payment times 100%. So what I'm going to say is, to work out my interest rate, I can take the interest I've been charged, $12.50, divided by the previous balance, $1,000, times 100%. And that gives me 1.25% per compounding period. Now again, because I don't know my annual rate, I can't actually work out my compounding periods, all right? But if my annual rate was, no, not even going to try and do this in my head. No, not going to try and do this in head. So what I want to ask you is this. Does that value happen regardless? Do I always have to use this first interest and my balance? No. Theoretically speaking, unless they're trying to be really tricky, you can take any interest rate, that 9.53, and divide it by its previous balance of $762.50, times it by 100, you will also get 1.25. Likewise, 6.53 divided by the previous values, right? So working out the tricks of how to use the values in the amortization table is really, really important. So we know, as I say, for this particular table here, my rate of interest is 1.25%. So if I wanted to find out the interest on this, right, if I was going to have table number 4, all right, and I had another $250, and I wanted to work out my interest, I would be wanting to work out 1.25% of my previous balance. And my previous balance in this situation would be $278.56. And again, if you want to remember how to do that, it's 1.25. Percent means divide by 100, of means times 278.56, and that would then give me the new rate of interest, okay? Happy with that so far? If not, stop the video, go back, watch it again, listen the whole video. It's so important you understand how amortization tables work. All right, so what type of things will they ask you for in an exam to fill in? Well, I've highlighted 4 of them here for you. So the first thing is, they might ask you to find the final payment. Right? They may ask you to find a final payment to clear. We'll come back to that a little bit later on. They might ask you to find an interest that will be charged. They'll give you the balance, they'll give you the rate of interest, they'll ask you to find this balance here. They might ask you to find a principal reduction, and they may ask you to find a balance, an individual balance on here. So any of those values there, in any of those columns, they're not going to ask you to find payment number. It'll be too simple, all right? But they could ask you to find any of those values whatsoever. And that's the point of the next 2 videos, or this video and the next one. All right, here's an example. Flora borrows $200,000 at an interest rate of 8% per annum, compounding annually. So that's great, all right? So because it's compounding annually, I don't need to worry about anything other than having a little r of 8%. Now, weirdly, we're not really going to use the compound interest, or sorry, the recurrence relationships anymore. We're just going to know that it's 8% of. She makes annual payments of $2,500. State the principal of the loan. All right, well, the principal of the loan, I can read, thank you very much, is $20,000. Calculate the initial interest charged on the principal. Right, so when you want to find the initial interest charged, it is always the rate of interest, 8%, or the monthly interest, or whatever else. So it's 8% of the value that we are looking to find out. And now, because it's calculate the interest charged on the principal, we want to find 8% of 20,000. How do I do that? Fire up my calculator, and I'm going to cover up part of my screen. So 8%, if you remember, is 8, where I see percent I do divide by 100, times, which is of, so 8% of, and 20, 1, 2, 3, hit enter, gives me $1,600. That sounds a lot of money. Have I done that right? Well, let's say yes. All right, so my interest there is $1,600. So now, automatically, I can put there 1,600. Let's put that one here. 1,600. Determine the impact of the first annual payment to find the principal reduction. This is a loan. And with loans, we always do the payment minus the interest. So in that situation, I'd put into my calculator 2,500 minus 1,600 will give me $900. So what that means is that my loan is only going to reduce by $900. Now that's actually real world. At the moment, my mortgage payment is about $2,000 a month, of which $1,000 is interest. So if you think about that, I'm paying into the bank $2,000. The bank is saying, well, actually, we're keeping $1,000 out of interest, which means my loan is only reducing by $1,000. And that's very much the concept that we're having here. All right, I've paid in $2,500. The bank are basically keeping $1,600 of that of interest, means my principal reduction is only going to go down by $900. So that's $900. Calculate the new balance. Well, I started with 20,000. I'm going to take off $900, and again, I'm not leaving this to chance. And that is going to give me $19,100. Now, what I have done here is very representative of what you'll be doing over and over again for amortization tables. And if you can work out the interest rate, or the amount of interest, the principal reduction, and the balance, you will be able to smash every single one of these questions. Flora borrows $20,000 at interest rate 8% per annum, compounding annually. She makes annual payments of $2,500. Construct an amortization table for Flora's reducing balance loan for the first 3 payments. Okay, well, we actually did the first one, so I'm just going to slow this down, or rather do it again, just time and time again, so that we can work out, right? And sorry if it is laboring this, but I can't tell you enough how important, because again, these are SAC questions. They'd love using amortization tables in SACs. All right, so she makes annual payments of $2,500. So the first thing is, all of these values here are going to be $2,500. Now, interest, don't think that we can work out interest and it's the same it isn't. Remember, the interest changes by the balance. So, first thing we want to do is say 8% per annum compounding annually. So the first thing I want to do is work out 8% of, what balance have I got? 20,000. Well, actually, I've already done that on my calculator. So what did we work out? That was $1,600. So that's $1,600. He says writing and highlighter again. The principal reduction, because this is a loan, it is the payment minus the interest, which you said was $900. And so that was $19,100. Ka-ching. Now, we do the next line. We've made a payment of $2,500, but my interest now is going to be different. Why is it going to be different? Because my balance has reduced. So now I want to work out 8% of $19,100. Fire up my calculator. Let's go here. All right, so now I want 8% of, copying that down, 100. Hit enter, it gives me $1,528. So now, 1,528. Sadly, a lot of people think that once you've worked out the interest once, that just gets copied down. That's not true. That would be simple interest. That's not going to apply here at all. Right, so I've got a new interest figure. How much is my principal reduced? Well, I paid $2,500. The bank are keeping 1,528 of it, so I'm going to do 2,500 minus my previous answer. Hit enter, gives me $972. Right, that's my principal reduction. So my previous balance was $19,100. I'm now going to subtract the $972 to give me 18128.00. Oh, nice. Notice how, because my interest rate has reduced, I'm starting to pay off more of my loan. We like that, thank you very much. What have I got to do now? Work out interest again. Well, how are we going to do that? I've got a new balance. So my interest rate is going to change. So rather than now using 19,100, I'm going to change that to 8% of 18128. Fire up my calculator. Let's copy that down. Delete that. 18128. Now I've got cents, so I've got to put that in, 1450.24. I've done the hard work now. What's my principal reduction? It's a loan, so I do my payment, 2,500 minus my previous answer. Tells me that this time my principal is going to reduce by $1,049.76. What's my new principal, I hear you ask? Well, it's my balance minus my principal reduction. So I'm not going to do that because I'm covering up my screen too much, but I would do 18128 minus 1049.76. Hit enter, it gives me every time. $17,078.24. And what I'm actually going to do is leave the last line to you. I don't want to make this video any longer than it needs to be, but can you now work out? Because what is important to notice is my payment is staying the same, my interest is going down, my principal reduction is going up, my balance is going down. All right, so that becomes really important and the basis of an amortization table. All right, question from the Cambridge textbook, and again, thank you Cambridge for letting me use them. Business borrows $10,000 at a rate of 8% per annum, compounding quarterly. All right, so we've changed. We're now compounding quarterly. The loan is to be repaid by making quarterly payments of $2,700. The amortization table for this loan is shown below. Calculate the interest paid on the initial balance. Well, this part A is asking you effectively to find that missing box there. Well, we know how to do that. Do I know my interest rate? Well, yeah, it's 8%. Because if you remember, it's 8%, but it's compounding quarterly. So my interest rate per line of this is actually 2%. So this value here, I want 2% of my previous balance. And how do I do that? I can only do that on my calculator. 2% of $10,000. Now you may be able to do that in your head. I'm not going to do that. I'm just going to go 2% of $10,000. 200 bucks. All right, so there we go. So automatically now I know that that interest is going to be $200. Ka-ching. Is there another way I could have worked this out? Did I actually need to do all that hard work? Well, again, understanding how amortization tables work is really, really important, because if you remember, my principal reduction for a loan is gained by this value minus that value. Oh, well, hold on a moment. I started with 2,700. It's gone down by 2,500, which means the bank must have charged me 200 bucks. So actually doing all that hard work of interest rates, although it works, there are other ways of doing it. So I suppose now the question is there another way for part, what is it? Calculate the principal reduction. So we're now going to try and find this value here. Well, how do I find that value there? Well, there are two ways of doing it. I can do my payment minus my interest. So I'm actually going to do that off here, 2,700 minus $150. Gives me 2,550. 2,550. But is there another way of doing it? Well, absolutely. We know that this value here minus that value there must be this value here. Or if I find the difference between those two values, it's got to be that value there. Now again, this might be too much too soon, but what I'm trying to show you is there's a hard way of doing it and there's an easy way of doing it if you understand where each of these numbers come from, all right? So again, if I did 10,000 minus the 7,500, I would get 2,500, yeah? So can I now work out the final balance here? Well, absolutely. In fact, there's only one way to do it, because this situation, you would have to do the previous balance of 4,950 minus my principal reduction. I don't think there's a quicker way of doing it off the top of my head. So again, let's do that. 4,950. 4,950. You can't see what's going on off screen, but my fingers. Minus 2,601 gives me 2,349. Ka-ching. Again, power of amortization tables are huge. All right. Now again, here's another example now with an annuity. Oh, now again, remember annuities, we take money out, but then interest gets paid in. Does that mean this changes the calculation? Well, let's have a look. Right, we've got our payment numbers. Right, I'm obviously taking 2,200 out from each of my months, so monthly in this situation. My interest seems to be changing. My principal reduction changing. So, state the principal of the annuity. Well, the principal of the annuity in that situation must be $12,000. The principal is my opening value. That's my opening value. And the amount of interest paid in the first month, well, the amount of interest in that situation was $60. So this, in that situation, was just reading the table. Calculate the monthly interest rate. We can do this now because the monthly interest rate is the monthly interest at 60 divided by the previous balance times by 100. Again, doing this off screen, 60 divided by 12, 1, 2, 3, times that by 100, if you will, gives me 0.5%. I don't need to multiply that by anything because it wants monthly interest rates. Then it goes on and says find the value of A and B. All right, well in that situation, I can't actually use any information in the table because it doesn't actually, actually yes I can. All right, because what do I know? That if I subtract these two values here, I'm gonna get B. So the first thing I'm gonna do is I'm gonna do 7709.30. I'm gonna subtract from that 5547.85 because that stands for my principal reduction. So I know that in that situation, B is going to be 2161.45. So I'm going to write that there, 2161.45. Well, can I now work out my interest? And if all else fails, look at what they've done to go from one number to this number to get to that number. How am I getting from 2,200, the 60, to 2,140? They seem to be taking it away. And again, for annuities, that makes sense, right? Because what I'm doing is, when you do an annuity, I've started with $12,000. I'm subtracting the $2,200, but they're giving me $60 in interest. So actually, my principal is only reduced by $2,140. All right. So again, that is important. So basically, this value here, subtract that value there, gives me that value there. Or if I do the payment, subtract the principal reduction, that will give me my interest. So again, if I do 2200 minus 2161.45, I'm going to get a fabulous value for A as, he says reading the calculator, $38.58. So $38.50, 5 cents. I think I said 58 cents. 38.55. Yeah. Now again, does that make sense? I think so, because my interest seems to be decreasing. If that value went up or was high, I'd probably start to go, I don't think so, I've made a mistake. Amortization table for investments. Now, when I'm paying in money, hopefully my balance is going to get higher and higher and higher. And you've got to make sure that for these questions, you understand the difference between an investment and a loan and an annuity. All right, so when you read the questions, I'd have it in your summary book. When you do an annuity and a loan, you do the payment minus the interest. When you are doing an investment, what you'll notice is that a principal increase, and notice the table here has become principal increase, is basically the payment plus my interest. The table works in exactly the same way. This balance plus this increase gives me my new balance. If I wanted to work out the interest, I do 3 divided by 1200 times 100, yada, yada, yada. All right, so example, amortization table for investments. Consider the following amortization table for a compound interest investment with monthly additions to the principal. Assume that interest compounds monthly. Complete 2 additional lines of the table corresponding to payment 4 and payment 5. Okay, so let's now fill in the first line of this column. So what I'm going to do is look at payment number 4. What is our payment? Well, they seem to be fairly similar at $50. So I'm going to say that payment number 4 and payment number 4 are sticking at $50. All right, seems to be reasonable. My interest, I've got to work out my interest. Do we actually know what our rate of interest is? Well, no, not at the moment. So what I need to do is work it out. So I've got my interest I can work out by taking an interest rate, divide it by my previous balance, and then come up with, multiply it by 100. So my rate of interest, in which case is going to be 3, divided by 1200 times 100. I'm going to fire out my calculator, but not on the screen if that's okay with you guys, because basically 3 divided by 1200, you should be able to do times that by what? 100 gives me a payment interest or a monthly interest rate, because they told me it was monthly, of basically 0.25%. Right, what does that mean? Well, it means that I can now use that to find 0.25% of any balance. All right, well, we know my previous balance for payment number 3 was 1359.4. $1,359.40. So what I'm going to do now is work out 0.25% of 1359.40. And again, everywhere I see a percent, I do divide by 100. Everywhere I see an of, I do a times. So again, 0.25 divided by 100 times that by 1359.40 gives me the staggering amount of $3.40. So $3.40. Now again, does that make sense? Is that a sensible value? Well, let's look back at what our previous one was, 327. It's certainly more. It seems to make sense. Principal increase, how do I get that? Well, in this situation, for an investment, we get our payment and we get the interest added on. So that's going to be $53.40. And then what am I going to do? Well, hopefully my principal increase was $53.40. I had $1,359.40. I'm just going to add them together. So $53.40 plus 1359.40 gives me the staggering amount of I keep doing that. I'm going to get out of this one day. 1412.80. And do we do it again? We absolutely do it again. But in this situation, I would now be working out 0.25% of 1412.80. All right, so again, I would fire up my calculator. I would type in 0.25 divided by 100 times this value here. That will give me my interest. How do I get my principal increase? I would do the 50 plus this value here. You can imagine that I'm not going to do this. And how would I get my balance? I would do this value plus this value here. Once you get used to doing these over and over again, life becomes so ridiculously formulaic that I defy any of you not to be able to do this. Working out these interest questions are really, really important. So here's some VCAA questions. Peanut invests $540,000 in an annuity, paying 3% interest per annum, compounding monthly. All right, got a lot of information here already. So there's an initial amount. Oh, that's it. So that's line payment 0. Thank you. 3% interest compounding monthly, which means my monthly rate is going to be 3 divided by 12, which again, I'm going to put that into my calculator. 3 divided by 12, which gives me 0.25%. That seems vaguely familiar. Her annuity will provide a monthly payment of $5,214.28 for 10 years. Ooh, that is a lot of money to live on. 4 lines of the amortization table for Pina's annuity are shown below. The information for payment number 3 is missing. What is the value of payment number 3? I know what it basically means is how much they are getting, right? So what are she actually taking out of her annuity? Well, as far as I'm concerned, that is going to be exactly the same as here. So I'm going to write 5214.28. Calculate the interest associated with payment number 3. Round your answer to the nearest cent. Well, I know now my interest rate per month is 0.25% of, and it has to be my previous balance. Well, because I'm looking at finding the interest for number 3, I'm going to find the balance of number 2. So that's going to be 261.78. Again, I hope you don't mind, guys. If I bring the CAS up, it actually obscures the view. So I'm going to do 0.25 divided by 100 times 532,261.78. Hit enter, gives me $1,330.65. Does that make sense? Look at my interest. Are all the values going up or are they going down? Well, they appear to be going down. All right, so I've got 1,350 dropping and dropping. That seems reasonable. What is my principal reduction? Am I adding these two together? Am I taking them away? Well, again, remember, my payment I take out, my interest gets added back on. So actually I want to subtract these two. And if you're ever not really sure, just look at these two values here and work out how you got that one there. So I'm going to subtract these values away. So what do we got? 5214.28, 5214.28. I'm going to subtract from that 1330.65. Is going to give me a staggering amount of principal reduction, $3,883.63. And what's the last part? Oh, it doesn't actually say that. Oh, that's awkward. I've gone on a bit. Oh, let PN be the balance of dollars of Pina's annuity after M months. Write a recurrence relation that can model this from month to month. Okay, well, let's delete these lines here because we know how to do a recurrence relationship. So we've got V0 is equal to 540,000, comma, V of n plus 1 equals. Now, what's my rate of interest? Well, if you remember, my monthly interest was 0.25%. That is my little value of R. So my big R is going to be 1 plus 0.25 divided by 100. Again, put that into my calculator. 1 plus 0.25 divided by 100 gives me my multiplier of 1.0025 V of n. Let's just give myself some room here and move that over. And then what am I doing? Well, it's paying out. So I want to then take away my payment of 5214.28. Now this would be a multi-part question, although I've crammed it all together on the screen. That's just for real estate or space. And basically, yeah, that's what you would be expected to fill in on your exam. And notice again, it's fairly formulaic. Deeper invests $500,000 in an annuity that provides an annual payment of $44,970.55. It's saying an annual payment, thank you very much. Interest is calculated annually. That's going to make life a little easier, hopefully. The first 5 lines of the amortization table are shown below. The principal reduction associated with payment number 3 is. Now again, we can do this in lots of different ways if you remember. The most obvious way, I think they're trying to get you to realize, is to do something with those 2 numbers there. Are we going to add them together? Are we going to take them away? Well, again, because it's an annuity, we would actually subtract them. That's one way of doing it. Alternatively, we should get exactly the same answer if we subtract those 2 numbers. Again, because the principal reduction is what's the difference between those 2 balances. I'm going to do these 2 subtracted from each other. So 449,060.08. And I'm going to subtract from that 422,051.93. Hit enter. It gives me, oh, I've done it again. Come on. $27,008.15. So which one of that? $27,008.15. C would be my correct answer. The crowd goes crazy. Or was that just in my head? Samuel has a reducing balance loan. Have you noticed these questions seem to come up quite a lot? The first 5 lines of the amortization table for Samuel's loan are shown below. Interest is calculated monthly, and Samuel makes monthly payments of $1,600. So whenever you've got a question, just check, all right? Is the payment $1,600? It is. Interest is charged monthly or calculated monthly, all right? So my mind now says that I'm going to have to do something with my annual interest rate. Interest is charged on the loan at a rate of 3.6% per annum. So my little value of R is going to be 3.6 divided by 12, which is going to be 0.3% per month. Okie dokie. Using the values in the amortization table, calculate the principal reduction associated with payment number 3. Again, if we're looking for the principal reduction, the easiest thing to do is take these 2 payments here and simply subtract them. That will give you the principal reduction for that particular section there. So again, let's put this on a calculator. 318,718. Oh, he says, why is that typing? 318,718.08, and I'm going to subtract from that 318,074.23. Hit enter. Gives me $643.85. Again, I'm checking the reasonableness of this. Does that make sense? It actually does. My principal reduction seems to be going up each time. That makes sense. Right, so calculate the balance of the loan after payment number 4 is made. So what they're now asking me to do is work out this value here. Well, we can do that. We're just going to take a little bit of effort. Obviously, this would have been worth more marks because you're having to do a multi-step equation. Right, let me see. Interest. How am I going to work out my interest? Well, I know I need 0.3% of that value there, right? So again, so I'm going to do 0.3 divided by 100 times, because it's of, and that value of 318,074.23. Hit enter. It gives me, striding highlighter again, $954.22. What is my principal reduction? How am I going to work that out? Well, I'm going to subtract those 2 values. Again, if you're not sure, do a test. That's why they give you these values, at least on one of the tables, so that it nudges you in the right direction. So 1,600 minus $954.22 gives me $645.78. And in this situation, I would have to do this value here minus that value there to give me what is left, he says. So 318074.23 minus 645.78, hit enter, and I get a staggering value of 317, what have I got? 428.45. Doesn't quite fit in, but there we go. Round your answer to the nearest cent. Ka-ching, I've even read that last part of the question. And there we go, that's the end of the video. Hopefully this has been useful. As usual, mathsguru.com, head over there, sign up, free to sign up. You've got downloadable lesson notes and the videos all in order and time codes and all that exciting stuff. And if you can, sign up to me or follow me on YouTube or subscribe on YouTube. Again, it just lets me know that you're watching. Hopefully you're finding these lessons or these videos useful. If you are, tell your mates, tell your teachers. Hopefully I'll see you in another one. And if not, you take care and please stay safe.